So what we're going to look at today is just a quick review of something that we've already covered in class, but just to give notes for people that might have been absent. We're going to look at our different types of transformations and our rules, or like I called them in class, little recipes that let us know what happens as we transform our point x and y under certain conditions. So we'll start with a translation. A translation is basically moving any point on your graph to the left or to the right or up or down or some combination of those two things. So this is the way we write it. This lowercase t means a translation. A and B are just numbers. They represent the change that you're going to do to this point x and y. So x and y is any point on a curve, and it's going to get moved by A and B. How does it get moved? So we have our original value of x plus A, and we have our original value of y plus B. And that will give us a new point, a new x and a new y. So on our adjacent graph, it says to show the translation of A being 4 and B being -1. So if my initial figure is A, B, and C, I've moved over 4 and down 1 to find A prime. I've moved over 4 and down 1 to find B prime, and over 4 and down 1 from C to find C prime. And that's what a translation is. A few things that you can tell from the graph. The shape, if it's a shape, will still be oriented the same way. So it's still facing in the same direction, but it's moved downwards and it's moved to the right because we have 4 and -1 as the movement out of our graph. So let's take a look very quickly at rotation. A rotation about the origin O with an angle of rotation of any multiple of 90 degrees can be written according to a rule. And we actually have 3 different potential rules here. So if we have -90 degrees, degree here, or 270 degrees, those two are actually the same thing. And if we have that rotation happening, our point x and y will be transformed into y -x. So the x and y will actually change place, and that x will become negative. If we have a rotation of -180 degrees or 180 degrees, because again, we remember those two angles are the same, our point x and y will become -x and -y. So we won't have a change in the placement of the x and the y, but they both will become negative. If either of those values is already negative, we have a double negative. It becomes positive. And then if we have a rotation of +90 or -270 degrees, our point x and y will become -y and x. So those are our 3 different rules for rotation about the origin. Now there are other possibilities. We can rotate by some non-90-degree multiple, but then we actually get into a little bit of geometry that we're not going to be covering with this chapter. So we're just going to work with these 3 different rules right now. And we're going to skip that example because we did it in class. So a reflection is our last type of transformation. And for us, what we're looking at is just a reflection about the x-axis. And the way we write that down is s with a lowercase x. What does that do to our point x and y? It changes it to x -y. So any x value will remain the same. Any y value will become negative. If it's already negative, it will become positive. And this is what it looks like here. So this is my x-axis, and I have a reflection around it. So all of my x points are still the same. And we can see that here. They're still at the same x value, but all the y values have become negatives. So if I've gone from the blue shape to the red shape, my x values are still the same and the y's become negative. If I'm reflecting about the y-axis, the way I write that down is s with a lowercase y. And what happens to my point x and y becomes -x and y. So the x will become negative and the y will remain the same. So why does that happen? Let's look at our graph here. This is our y-axis. And we can see here that all of our y values are the same. So this point C is at the same height, B is at the same height, and A is at the same height. But our x values have now become negative. So that's what ends up happening. Our value of C, the x value, becomes negative and becomes C prime. Same thing for B and B prime and A prime. So now that we've covered a little bit of a review, our next video will be some examples of how will we actually see this in questions and what can we use this for.